Here's an explanation on the Algebra 2A OWL pages, number 6. So these are transformations of the parent functions. Number 6, the cube root of 2x plus 1. It's going to be one of the first forays into a dilation. What does that number mean on the outside? Or sorry, on the inside. Let's analyze it first. This is a cube root function. And that number on the inside, that 2, it is going to be horizontal compression by 1/2. It's hard to kind of imagine that because you see a 2 in there, you think, okay, it's going to double it. But what really happens is that input only needs to go half as far to get the full effect of the cube root. It only needs to go half as far to get the original points. What I mean by that are, well, let's get to it in a moment. The next thing, I'm going to go up 1. That's next in the transformation. So here's an option. I'll give you 2 on this one. First, I'm going to put in the original parent function, cube root of x plus 1. So I'm just going to sketch cube root of x plus 1. I should be pretty good at knowing that that is now has a center point at 0, 1, and then go 1 over, 1 up, 1 to the left, 1 down, and then 8 over, and 2 up, and 8 over, and 2 down. This is my original. Cube root of x plus 1. I'll label that cube root of x. Now I'm going to deal with the horizontal compression by 1/2. All the x coordinates are just going to be reduced, cut in half. So let's see, I'll change it to blue and make this f of x blue. So what used to, and I'll zoom in really closely, that 0 point, a new important point, is not going to change. But what used to be at 1, 2 is now just going to be 1/2, 2. Something like this. And what used to be 8, 3 is now just going to be 4, 3. It's been horizontally compressed. So it's as if you've got, if this cube root function is like a wire, and I've been pushing it in, I'm horizontally compressing it, it's bowing out a little bit. It's the mirror image on the other side. If it was negative 0, negative 1, it would be negative 1/2. Sorry, if it was negative 1, 0, it's going to be negative 1/2, 0. And that other point was negative 8, negative 1, it would be negative 4, negative 1. Something like this. Is that right? Wait a second. Negative 4, negative 1, yes. So it's going to be something like that. I know, puppy. It's my dog. It needs to go out. Another option that I'd like to share with you is to, if you're not in the visual part, if you'd like to kind of look at points. Here is another option. I'm not sure if you would like to go this way, but want to give it to you, is to examine that cube root of 2x. We're normally used to looking at points at like 0, 1, 8, negative 1, and negative 8, right? Those are our original inputs into things that are nice and easily cube rootable. But this 2x on the inside kind of convolutes it a little bit. So if we put in a 1, we're going to get the cube root of 2. We don't really know that as much. If we put in an 8, we're going to get the cube root of 16. So I would offer you to maybe change your points a little bit. For example, if I want easily cube rootable numbers, 0 is going to be a good one. But another one is going to be, the next easily cube rootable number is when it's equal to cube root of 1. So I'm going to set 2x equal to 1. And that means x equals 1. X is going to be 1/2. So when I put in a 1/2 into there, it's going to be come out quite a little cleaner. I'll show you what I mean in a moment. The next easily cube rootable number is 8. So if I want that input inside the cube root to be 8, x has got to be 4. Same thing with the opposite. It's going to be negative 1/2 and negative 4. And if you do this work a little bit up front and find the easy ones that make things nice and easily cube rootable, the outputs are going to be easier. So I'm going to put 1/2 in here. That's the cube root of 1 plus 1 would give me 2. When I put a 4 in there, I get the cube root of 8. Hey, that's nice. That's 2 plus 1 is 3. And when I put a negative 1/2, that's negative 1. Negative 1/2, 0. And negative 4, that's the cube root of negative 8. That's negative 2 plus 1, negative 1. These are now, that's a 0, 1. These are now the points that I originally found out by visualizing it, but I changed the input a little. That helps me find those points as well. There's other options. You can do a table method, or perhaps, I guess, guess and check. Just put in some points. But